Good day, students. How are you doing? Today, we'll be moving down to chapter 17. We'll be dealing with static electricity. Let's start the class. Now, let's deal with charging and discharging. We have to drag the words into the correct boxes. An electrostatic charge builds up on a car and then discharges through you. When you touch the metal door, you have probably rubbed a balloon on your clothes or hair and seen how it will stick to a wall or ceiling. Static electricity is generated by rubbing a plastic ruler with a cloth, which becomes electrically charged. Let's check. Static electricity. Let's drag the words into the correct boxes to give it a meaning, that is a definition. Attraction and repulsion gives rise to two types of static electricity. The two types of static electricity are positive and negative charges. There is a force electric charges exert on each other. Like charges repel and unlike charges attract. Like charges are charges of the same type, while unlike charges means charges of different types. Magnetism arises from magnetic poles, while static electricity arises from electric charges. Let's check. That is it. Now, how do we then explain static electricity? Let's go. Amber is a form of resin from trees which has been fossilized. It looks like clear orange plastic. The Greek name for amber is electron. And this is where the name of tiny charged particles, electrons, that account for electricity comes from. It is the force of friction that causes charging. When a plastic rod is rubbed on a cloth, friction transfers tiny particles called electrons from one material to the other. If the rod is made of polyethylene, it is usually the case that electrons are rubbed off the cloth and onto the rod. We check. That's correct. Now, we also move further by still explaining static electricity. You have to fill in the missing words. Now, electrons are part of every atom. They are negatively charged and they are found on the outside of the atom. Since they are relatively weak held in the atom, they can be readily pulled away by the force of friction An atom has no electric charge. It is neutral. When an atom has lost an electron, it becomes positively charged. Since a polyethylene rod becomes negatively charged when it is rubbed with a silk cloth, electrons are being rubbed from the cloth onto the rod. Let's check. That's correct. Now, let's deal with charging by induction. You have to fill in the missing words. Suppose a balloon has a positive charge. It must be attracted to a negative charge on a wall. The wall is neutral, but its atoms are made up of both positive and negative charged particles. When the balloon is brought close to the wall, its negative charges move towards the balloon because they are attracted by it. Negative charge has been induced on the wall. This process is known as charging by induction. The same process occurs when the charged rod and cloth attracts scrap of paper. The negative rod induces a positive charge on the paper by repelling electrons away. The positive cloth attracts the electrons. Charging by induction can be used to charge a metal object. That's correct. Now, let's deal with electric fields and electric charge. We have to drag the following words into the correct boxes. A charged object can affect other objects, both charged and uncharged, without actually touching them. For example, a charged plastic rod can exert a force on another rod placed close by. This indicates that there is an electric field around a charged object. Any charged object placed in the field will attract a force on it. A magnet does not attract electric charges. A charged object does not attract a magnet. That is it. Now, how do we represent an electric field? You have to draw the words into the correct boxes. A charged object is surrounded by an electric field where it experiences a force. That is, it will be attracted or repelled. Electric fields are represented by lines of force. The lines of force are shown coming out of a positive charge and going into a negative charge. A positive charge is repelled by another positive charge and attracted by a negative charge. When two oppositely charged objects are placed close together, they attract one another. Two objects with the same charge repel each other. Let's check. That's it. Now, how do we describe an electric charge? We have to fill in the missing words. Electrons are charged particles that are transferred from one object to another when they are rubbed together. Electric charge is a property of the particles that make up atoms. Charge is measured in coulombs. An electron is a negatively charged particle which is much smaller than an atom and only weakly attached to the outside of the atom. It is held by the attraction of the positively charged nucleus of the atom. The nucleus is positively charged because it contains positively charged particles called proteins. An electron has a tiny amount of electric charge. The electron charge is so small. Let's check. That's correct. Now, look at this. When you have an atom, now atoms are embedded in an element. For instance, if you go to chemistry and check the periodic table, all what you see that are arranged one after the other are elements. In the elements are embedded the atom. So for the atom, you know that they are the smallest indivisible particle that can take part in a chemical reaction. So inside an atom, we have the nucleus. The nucleus houses three major particles. We have electron, proton, and the what? Neutron. Now, charges that is on the electron, proton, are basically measured in what? Coulombs. Don't forget that electrons are negatively charged, protons are positively charged, while neutrons are electrically neutral. Why we say neutrons are electrically neutral is because they have no what? Neutrons have no charge. Now, the charge on an electron is minus 1.60 times 10 raised to the power minus 19 coulomb. Why? Because the electron is negatively charged. The charge on a proton is plus 1.60 times 10 raised to the power minus 19 coulomb. Why? Because the proton is positively charged. And then don't forget that the mass of an electron differs from the mass of what? The proton. The mass of the electron is far, far smaller to the mass of the proton. The mass of the electron is 9.11 times 10 raised to the power minus 31 kilogram. While that of the proton is 1.67 times 10 raised to the power minus 27 kilogram. Now, let's deal with this question. How many of the following materials conduct electricity? If you should look at aluminium, aluminium is what? A metal, all right? And being a metal, it's going to conduct electricity because electrons can what? Flow through it. The same thing with what? Silver, the same thing with iron. But for plastic are not what? Metallic materials, they are not conductors. Rather, they are what? Insulators. So out of these four options that we have, it is only what? Three that can conduct electricity. Therefore, we pick three. That is it. Now, looking at this question again, charged particles are emitted from the cathode ray of an oscilloscope. What is the name and the charge of the particles? Now, when we are dealing with a cathode ray oscilloscope, The major charge that usually emitted is what? An electron. And don't forget, I made mention that what? Electrons are always negatively what? Charged. While the other ones, proton is positively charged, and the neutron is what? Electrically neutral. That is, that's no charge. So whenever you see an electron that is emitted from a cathode ray oscilloscope, it is what? Always negative. So we pick that and check. That is correct. Now we are to choose the correct statement out of these three. Neutrons are negatively charged. The answer is no. Neutrons are positively charged. The answer is no. Neutrons are electrically neutral. Yes, because they have no what? They have no charge. So we check. That is it. Also, we have to choose the correct statement. Forces that exert electric charges on each other shows that like charges attract and unlike charges repel. No. Why? Because this does not obey the law of what? Electrostatic forces. Let's take the second statement. Forces that exert electric charges on each other shows that unlike charges attract while like charges repel. This is law of electrostatic what? Charges. This is correct. But we won't pick it without checking the third option. Forces that exert electric charges on each other shows that positive charges are radially directed inward. No. Positive charges are always radially directed outward. So the second option is correct. Now we've come to the end of today's class. Do well to check our website www.edubbey.com for more of our interactive videos and our interactive content. Bye for now.